Hey class, this video is on 6.1b, Graphing Rational Functions, Day 2. Now hopefully this doesn't confuse you because it's going to, I'm going to not use the parent function this time. So I graphed the simple rational functions with the parent function, and these ones are a little bit more complicated and I don't use the parent function. So hopefully it doesn't confuse you, but hang in there. All right, so remember simple rational function, or the hyperbola was y equals 1 over x. It gives us this hyperbola with the symmetrical branches. The domain is all real numbers, except for in this one, x can't be 0. The range is all real numbers, but y can't be 0. And then we have the vertical and horizontal asymptotes that correspond to those values. X equals 0 and y equals 0. So that's our parent function review from yesterday. So that's a very simple case. When we get a little bit more complicated, so when we have like two linear functions divided by one another, like two polynomials that are both linear, then the rules change a little bit. So we still have a vertical and horizontal asymptote, but how you find the vertical asymptote, it's the x value that makes the denominator 0. Equal 0. So how you find that value, sometimes it's obvious, but if not, you take cx plus d, you take the denominator, whatever it is, you set it equal to 0, and you solve for x. Then the horizontal asymptote will be the line y equals, and you take your coefficients a over c. So whatever your leading coefficients are of those two polynomials that are being divided out front, a over c, that's your vertical asymptote. So here's our first example. So this one, whatever makes the denominator equal 0, so this one's kind of obvious, it'd be -2. But if not, you take the denominator, you set it equal to 0, and you solve for x. So solving for x, we'd get x equals -2. So that is my vertical asymptote because it crosses the x-axis at -2. Then your horizontal asymptote is a over c, where a is 1 and c is 1. Those are my leading coefficients in each polynomial. So 1 over 1, or just y equals 1. So that's my horizontal asymptote, goes through the y-axis at +1. So now my hyperbola will be, the branches will be reflected over this shifted point of -2, 1. Which means my domain and range will correspond to those values. Domain will be all real numbers, except for that x will not equal -2, because it makes the denominator 0, and you can't divide by 0. And the range is all real numbers, except for y is not equal to 1. So for this one, we make an xy table, and we are just going to use the original function to plug it in. So, which means I need to decide which values of x I need to choose. So I'm going to look at my vertical asymptotes at -2, and I'm going to choose two values on the left side of that. So like maybe -4, -3, and I got -2, and then I have -1 and 0. So I'm going to choose the two to the left and two to the right. So -4, -3, -1, and 0. And then I'm going to plug these back into the original equation, into here. So if I plug -4 in, you're going to get -4 minus 1 over -4 plus 2. That'll be -5 over -2. So 5/2, or 2.5 is maybe easier to graph. Then plugging in -3. -3 minus 1 over -3 plus 2. So I always evaluate the numerator and the denominator separately and then divide second. So if you put in a calculator, you have to be careful that you don't just put it in as -3 minus 1 divided by -3 plus 2, because the calculator will do this part first. So if you are relying on the calculator, make sure that you use some parentheses tell the calculator to evaluate the top, -4, divided by -1, so that you for sure get the value of -4 out. So you have to be careful that you evaluate it correctly. Plugging in -1, I got -2. Plugging in 0, I got -1/2 or -0.5. Then we graph them from the actual point, or from the actual origin. So we want to graph from 0, 0. Because we plugged them into the original equation, we're using our original origin to graph. So -4, 2.5 is right there. -3, oh, is that supposed to be +4? I'm sorry. Two negatives over here make a positive. I was gonna say it's not making a hyperbola. So -3, +4. And then I can use those 2 points along with my asymptotes to finish drawing the hyperbola, because I know it's going to approach this positive or -2 but never cross it, and then it's going to come down, it's going to approach this 1 but never cross. So I'm getting really close to those asymptote lines but never crossing. Then I'm going to graph the point -1, -2 from the origin, from the 0, 0. So -1, -2, and then 0, -0.5. And then I'm going to, again, approach the asymptotes, get really, really close, but then never cross it. And there you can see my two branches of my hyperbola. They are mirror images of each other. All right. I'm going to at least do one more for the video, and then if you want one more example, you can look at the notes. So we find the vertical asymptote again by taking the denominator, setting it equal to 0, and solving for x. So this one's maybe not as obvious to what x would make the denominator 0. So if you set it equal to 0, and then you have two steps here, you have to subtract 3 and then divide by 3. So I'd get x equals -1. So that is my vertical asymptote. Then for the horizontal asymptote, it's y equals a over c, where those are your leading coefficients. So a is 1 and c is 3. So y equals 1/3 is my horizontal asymptote. So you're just going to have to draw that as best you can, 1/3, 0.3 above 0. So I switched to red because it was skinnier marker. So, okay, then we make an XY table. And we fill in, so 2 to the left. So my horizontal or my vertical asymptote's at -1. So you need 2 to the left of that, like -3, -2. And then 2 to the right, like 0 and 1. And then you plug them back into the original equation. So you plug them back into x minus 2 over 3x plus 3. If you're doing this in a calculator, you need to make sure that you do the top in parentheses, -3 minus 2, then divided by, then the bottom, 3 times -3 plus 3. Because you want to make sure you get -5 divided by, this would be -9, plus 3 be -6. So I got 5, 6, which is 0.83 repeating. Positive. So if I plug in -2, I'm getting -2 minus 2 on top, divided by 3 times -2 plus 3, be -4 divided by -3, which would be 4/3, which is 1.3 repeating. Continuing that, plugging in 0, I got -2. no, negative 2/3, so negative 0.6 repeating. I was looking at the wrong one. And plugging in 1, I got negative 0.16 repeating. So I got all decimals on that one. So graphing those, remember that we're going to graph from the 0, 0 point this time, like from the origin. So negative 3 to the left and then up 0.83, so just about to 1. And then negative 2, 1.3, just above there. Those give me 2 points, just enough to make my hyperbola get really close to the asymptote. I wasn't drawing very well there, but close to the asymptote, but never crossing it. And then the point 0, negative 0.6 repeating, just about negative a half. And then 1.16 repeating, negative. And then using those 2 points to draw my hyperbola. Getting really close to the asymptotes, but not crossing. The domain will be all real numbers, except for the x will not equal negative 1. That's my vertical asymptote. The range is all real numbers, except for the y will never equal a third. Gets really close to that line, but doesn't cross. I do have 2 more examples done in my, or at least 1 more example done in my notes if you'd like to look at that last example. Or come in and I'll help you with it. Have a good night.